Hello everyone, my name is Jonas Johansson and I'm a software architect in the NSO PLM team. The title of this session is Standard Yang-based Network Orchestration. And here we present our experience of managing network devices using standard Yang such as OpenConfig. The presentation has two parts. We'll begin with third-party Yang NEDs and the framework we have developed for building better NEDs based on device Yang models. We'll discuss what third-party Yang NEDs are, how we create such NEDs, what me and the NED team make to make this work, and what you must do yourself. We'll introduce a small learning lab walking you through the steps of creating one of these NEDs. In the second part, we'll discuss standard Yang models in general, what different standard Yang models exist, how NSO handles standard Yang models, and how devices does it. And some pitfalls associated with standard Yang models will also be touched. At the end, we summarize and talk a little bit about when and how to use standard Yang models. So, we will be using the term third-party Yang a lot in this presentation. So let's start by exploring what that is. A third-party Yang is any Yang model not implemented and owned by the Cisco NED team. There are different classes of third-party Yang models. The first is open standard Yang models. So these are models from IETF or OpenConfig or other standard organizations. There is also native Yang models from other vendors and native Yang models from Cisco OSS. These Yang models are obviously owned by Cisco, but they are not owned by the Cisco NED team. And as such, we are not free to do whatever we want with them. Another way of viewing this is that all Yang models that come from devices are third-party Yang models. This contrasts with the Yang models developed by the NSO NED teams for use for, for example, CLI NEDs, which are written from scratch and owned by the NED team. Third-party Yang NEDs is typically used with model-driven protocols like NETCONF and RESTCONF. NETCONF and RESTCONF are well-known IETF protocols and has been used by devices vendors for quite a while. gNMI is more recent, at least outside of hyperscalers. It's increasingly popular though, especially for telemetry, but can also be used for deploying configuration. gNMI and OpenConfig has a special relation. gNMI was created by the same group that develops OpenConfig models. Alright, so let's see what we have to offer when it comes to NEDs for third-party Yang models. Hopefully everyone here is familiar with the concept of NEDs in NSO, but in case someone isn't, I'll start with a quick recap. NEDs stand for Network Element Driver. NEDs are the drivers which allows NSO to communicate and orchestrate devices. NSO NEDs handles all outbound and incoming operation between NSO and devices, transforming the data and actions as necessary, such that it's understood by both ends. The NSO NED team has implemented many NEDs for all kinds of devices and management interfaces, including everything from basic CLI devices to the latest programmable interfaces. Currently, we have about 170 NEDs, of which 80 or so. There are some differences between traditional NEDs and third-party Yang NEDs, and we'll look at that in the next couple of slides. If we start with traditional NEDs, so a traditional NED as developed by the NSO NED team consists of two parts. One or more YANG models, which define the API used by NSO when interacting with a device. A protocol driver implemented in Java. It can implement SSH, SNMP, REST, or whatever else the device uses. Both the Java driver and the YANG data models are implemented and maintained by the Cisco NSO NED team. Typically, a separate protocol driver must be developed for each device. Everything is owned by the NSO NED team and is released and delivered to customers as a ready-to-use package. After users have installed the NED package in NSO and configured the device instance, they are ready to go. Development of these NEDs is reactive. Only use cases and configuration requested by customers are implemented and supported. Third-party YANG NEDs. The NSO NED team still implements the Java driver for the NEDs. However, since drivers only have to work with standard protocols, we can reuse the same protocol implementation in all NEDs for a particular network management protocol. In contrast to traditional NEDs, third-party YANG NEDs are released and delivered without YANG models included in the package. Hence, some extra work is needed when third-party YANG NEDs are first installed before we have a fully functional NED. To support this, we have developed a build system, including auto-patching of YANG files. This is a little bit This is partly speculation, but it's likely that development of these NEDs will be less reactive than traditional NEDs. If the models for a device are in good shape and it's well supported in the backend, no patches will likely be needed. Things will just work. Alright, so why are not the YANG models included in the NED? And there are several reasons for this. First, there is the legal reasons. Cisco is not allowed to redistribute native YANG data models from belonging to other device vendors. Another big reason is that all different version bundles of the YANG models. Different OS versions for a certain device are typically using different models revisions for at least some of the YANG data models, and an attempt to cover all OS versions would quickly lead to an explosion of different NED versions. One good example of the latter is iOS XR, where currently about 50 different firmware versions are supported, all of them using different module revisions of native and OpenConfig YANG data models, at least to some extent. That's what we do. Now let's look at what users must do to get a fully operational YANG NED. Here's the typical workflow. Step 1 to 3 is the same as for traditional NEDs. We download the NED from software.cisco.com, we install it in NSO, and we onboard a device. At this point, a traditional NED is ready to use, but for a third-party YANG NED, we now must figure out what modules are supported by the device, and then select the models we need for our project. This is typically use case dependent. We download the YANG models and we download the YANG models we are interested in, and we rebuild the NED packet. As part of this step, we automatically apply fixes for various device and module issues. After a successful build, we reload the packet and we are ready to use the NED. If something goes wrong in the build step, you can report an issue to the NED team and they will issue a patch for the NED. So let's look a little bit at selecting the YAG models. It's really two questions. What model should I include in my NED, and practically how does the tools help me do it? So we recommend that you only include the YAG models required to support your use case. There are many reasons for doing this. You get a smaller NED, and that means that the NED loads faster. The schemas consume less memory in NSO, and schema lookup is also faster. Get set operations are faster too, since the NSO only has to worry about the models included in the NED. And finally, there is a much greater chance that the NED can be used with multiple device OS versions. And this is because if there are fewer models in the NED, there's less chance as one of them is updated between OS versions. And NSO will not detect any version mismatches between the NED and the device. Selecting modules is easy. You can filter modules using regular expression. This is powerful and very flexible, but it will get you exactly the modules you want, but can get very complicated. And for that reason, we also provide a pre-configured download profile. For instance, a profile that downloads only OpenConfig YAG files, or one which download only YAG modules required for some use cases you are interested in. And new download profiles for other scopes can be added by the NSO NED team upon request. Downloading the right YAG files involves many choices and differs depending on the management protocol. For NetConf, it's usually easiest to download the modules directly from the device using the getSchema RPC. This is sometimes possible with RESTCONF, but less common than NetConf. If downloading from the device isn't supported, another source must be used. And to make all of this as easy to use as possible, the third-party YAG NEDs comes bundled with tools that support automatic download from devices, public Git repo, or an archive provided by the vendor. And when fetching the YAG modules, we automatically resolve all dependencies by checking the include and import statements in the YAG modules. And finally, if you have another way to get your hands on your YAG models, that works too. As long as we get them in the correct place, we are happy. So this is just a screen dump showing the output from downloading from the download tool. We see that we use the OpenConfig profile, and we also see how the download tool automatically fetch imports without being listed in the profile. Once we have the YAG models, the next step is to rebuild the NED. And just go to the source directory in the NED package and enter make rebuild. Unfortunately, it's rarely straightforward. Anyone that has tried to build OpenConfig models has likely seen errors like these ones before. So unfortunately, bugs in third-party YANG models is very common. It's usually caused by bad YANG constructs, for example, a bad XPath statements or missing prefix or something like that. And this applies to OpenConfig as well as under other standard YANG module families and also native vendor modules. And it's especially frequent in older versions of the modules. A particular common source of bugs is the custom augments and deviation that device vendors use to extend or limit the standard YANG models. And it is of course possible to manually fix these bugs by manually editing the files before building the NED, but it is very tedious. And this is when the built-in YANG patch tool comes in handy. This tool can automatically find and fix many of these bugs. And here we have a screen dump showing it in action when invoked as a CLI command in NSO. You'll rarely have to use this tool directly, however, because to make it more user-friendly, we usually invoke the YANG patcher automatically when we build the NED. So in that case, the end user won't even notice this additional step and things will just work. Not all YANG errors are detected at build time. So in these cases, the YANG is actually syntactically correct. That means that the patch tool can't help us. And when this happens, we require custom fixes. We usually refer to them as YANG recipes. A common example of these class of errors is when the YANG doesn't match what the device actually do. For example, we have a too restrictive must statement in the YANG model, which will cause a validation error in NSO when we do a sync from. And just as for download profiles, we can add new YANG recipes to the NED upon request. There are many other runtime problems. There are devices with various non-standard behaviors. Some devices contain return config containing dirty data of various kind, for example, invalid values, wrong type, outside allowed range, and so on. Another class is devices which returns unmodeled data, i.e. data not specified in the YANG model. We've also seen badly implemented protocol agents. In particular, this seems to apply to RESTCONF. An example of this is non-standard operations are required to deploy a configuration. Then there are two slightly different ways in which devices set additional leaves in response to configuration changes. Auto-configuration is intended device behavior and happens when a device sets additional data in response to a configuration change, safe typing for users in human-oriented user interfaces like CLI. Aliasing is unintended and happens when the device exposes the same configuration data in multiple model universes. And this will happen if you mix OpenConfig models with native models in the same NED, and is one very good reason for not doing so. Both auto-configuration and aliasing result in out-of-sync problems with NSO. Finally, there are devices where certain config cannot be set at all. These are the worst category of errors. So what can the NED fix? The NED can fix most of these errors too, using various kind of quirks and transforms in the NED Java driver. We refer to these quirks as runtime recipes. Just as the Yang recipes, these recipes are typically added upon request, so it's important that any runtime issues you find are reported back to the NSO NED team. One thing we can't fix is devices that do not support modifying certain configuration. For example, the device rejects configuration due to validation errors not reflected in the Yang model, or won't accept valid configuration depending on the existing configuration. Hence, it's very important that you validate your use cases on the device before using the NED. Make sure that the configuration you are planning to apply is really accepted by the device. Third-party Yang NEDs are still a relatively new thing, so there are not that many NEDs available yet, but the number is slowly growing. We will gladly implement new third-party Yang NEDs if requested, so if you need a new NED for a certain device, please file a request. At this point, some of you may be confused as to what the NetConf NED is. There are now two kinds of NetConf NEDs, and it's important to understand the difference. The classic definition of a NetConf NED is the build-it-yourself offering we always supported in NSO. This is what the NED Builder tool and the low-level Linux command bundle with NSO is used for. This type of NED uses NSO internal NetConf client. It's certainly a valid option, but mainly works for the sunny day scenario, when you have the standard conformant NetConf agent in the device, good Yang models, and no auto-config aliasing issues. This class of NEDs are free in the sense that the tools for building classic NetConf NEDs are included with NSO. And NED built using these tools are not supported by the NED team. And then we have the new third-party Yang NED type for NetConf, maintained by the Cisco NSO NED team. This NED type is using its own NetConf client implemented in Java. And since it's a separate implementation, it's possible to adapt it to work around various runtime issues devices suffer from. And as we've seen, this NED can also automatically fix buggy Yang models for you. These NEDs are developed and supported by the Cisco NSO NED team, and you pay to use them just as you pay, for example, CLI NEDs. We have implemented a learning lab for you to try if you are interested in learning more about this. It goes through the necessary steps involved when working with third-party Yang NED. To make it a little bit more interesting, we based the tutorial on iOSXR, OpenConfig, and gNMI. It's production, but it's not important for now. You can see a link to the website. That was third-party YAG-NEDs. And in this, we will talk about what standard YAG models are available and to use them. There are several groups publishing standard YAG models. There are IETF, OpenConfig, and other. Standard models promise to simplify the user's understanding and consumption of these devices, of the device functionality. The holy grail of device management is standard management protocols with standardized models giving users a single interface for all devices. We are mostly there with management protocols, but when it comes to the models, it's not exactly how things is turning out in practice. While standards are great, users often want features beyond the standards and development to be faster, neither of which works great from a standards perspective. When you start your automation journey, your first step is often to inspect your device to understand what models data. Another place for finding similar information is yagcatalog.org, where you can search for YAG models from standard organization and device vendors, which contains the functionality you are interested in. Catalog also allow you to validate models using the major YAG toolchains. This helps you assess their respective maturity. And even if it's hosted by IETF, other standard organizations as well as many vendors publish their models there and allow you to download the modules from there. You can view yagcatalog.org as the hub of the world for YAG modules. So what is OpenConfig? Is it a standard? Well, not exactly. OpenConfig themselves say that standardization, while important for interoperability, is a lengthy process. And they believe that there is value in someone charging ahead, working with vendors on implementations to gain experience with models that hopefully will inform future standards work. In practice, that is not how things have turned out. Organizations have not picked up and standardized OpenConfig models, although it's certainly possible that some insight has informed other standards work. Traditional standardization bodies take a long time because it's a consensus-driven process involving many companies and other groups, including discussions and voting and more discussions and more voting. In OpenConfig, there are a few people that decide what goes into the models. They certainly talk to vendors, but the decisions are made by a small group. And this is obviously much faster. But since fewer points of view are considered and the people making the decisions are different from the people implementing the models in the devices, there is a greater chance that something is missing in the standard. Still, their work can be seen as a common language and request for base features across vendors. All right, so what models are used in practice? First of all, you should note that this is data is not based on a proper market research. It's from our limited vantage point of people automating networks using NSO. For provisioning, CLI still dominates. And after CLI, we see NetConf with proprietary models, and followed by NetConf using augmented deviated standard models, and we also see some RESTCONF with native models. For telemetry, gNMI with augmented deviated OpenConfig seems to be the most popular option, followed by OpenConfig over RESTConf, and after that NetConf with native models. The latter using yang patch, yang push. Alright, so what about OpenConfig in particular? Can we use OpenConfig models in NSO? And if yes, how does that work? And how do devices implement OpenConfig? NSO is model driven and will happily use any kind of yang as long as it's valid. Earlier version of OpenConfig models were not terribly valid, but the situation has drastically improved with recent OpenConfig versions, meaning newer than 21 or so. Works are still there, and their style is a little different from what most people use, but we are certainly moving in the right direction. However, most devices in the field, if they support OpenConfig, still use models, the old models, even in recent OS versions. That often leads to problem when we try to use the OpenConfig interfaces. It's still possible to make things work, but it's not uncommon to have to make many, meaning hundreds of fixes just to make the yang models compile. And when you get into compile, there are still other problems you discover when you try to connect to the device, or you try to sync the configuration, for example. So think long and hard before you use old OpenConfig with NSO. Alright, so that was NSO. What about devices? What does it mean when someone says that a device supports OpenConfig? And are all devices the same? Say we have a device with a management interface. Architecture of the we have the management interface, a database where the configuration data is stored, and applications which read the configuration data from CDB and program the hardware to do the right thing. What if we want to have a second management interface or support a second yang model family? Well, you can simply add another management interface and another database. That would mean that we potentially have two different device configurations, one submitted using the first management interface and a different one from the second. Which database should the application read from when they program the hardware? They obviously have no way to know. This system would be schizophrenic. Instead, management interfaces are built on top of each other, with some mapping layer in between. The mapping layer translates between the second management interface and the original management interface. All config changes, regardless of what management interface is used, end up in the same database, and the applications have a consistent view of the configuration. They don't know and they don't worry about where the config came from. They just do what they are told. This means that OpenConfig capable system comes in two basic flavors. One kind that OpenConf has OpenConfig as a shim layer, which is then translated into native models by a mapping component. The other has OpenConfig as the native model that the whole system is built around. Native OpenConfig is only an option if you start from scratch, and in the real world, pretty much all the big players already had products on the market when OpenConfig was introduced. They certainly did not start over to build OpenConfig center designs. Instead, they added a shim layer on top of the existing management infrastructure. This is true for all the large Cisco platform, and it's also true for most other vendors. All right, what about that mapping component? You can think about the mapping component as a mirror or some other magic act. The purpose of the mapping component is to make something that looks and behaves in a native way to appear and behave naturally in a transformed way. This requires a lot of smoke and mirrors, and the projected image may sometimes get a bit fuzzy along the edges, even when the results are as good as intended. In simple cases, it's straightforward, but when the pawn begins to move, the queen must move too, and in the same way. And when the pawn waves an arm, so must the queen. Implementing all this transformation trickery is obviously quite demanding. There are often areas that are outright impossible. Some aspect of the transformed model may have no counterpart in the native model, or the value choices may not have exactly the same meaning across the model families. Another thing is that the mapping part and the standard models typically see less use than native core functions, and therefore may be less well tested. And no matter how careful you are, corners will necessarily have to be cut. The user experience of such cut corner is, I found a bug. And they are not wrong. If I can apply certain configuration one way, why can't I do it the other way? Or I apply this configuration, but when I view it through OpenConfig, some values are missing or have changed. And still, it's the best that can be done. So what is better, to use OpenConfig models or native models? The native models covers all the functionality the device has to offer and is usually very well tested. OpenConfig is not exactly standard, but it does provide a level of commonality between devices, and this is attractive to many users. But if not all OpenConfig models are implemented by a particular device, and even when models listed as supported are likely not fully supported, and furthermore, there are bugs in the implementation, you may be forgiven if you want to look for alternatives. And considering this, we often see people trying to paper over the holes in the standard models implementation by mixing in native models. And this is attractive. It seems like a viable option because the scope of the native models is wider, and the native models contains more functionality, usually everything the device does. So people try to create network service application which mostly uses OpenConfig, but also a few native items. That usually doesn't work, at least not in the way you expect, because these two model families touch the same configuration data, and when combined in transaction, it's likely that they will interfere in unpredicted ways. What does work is that if you begin day 0 to configure your using device models and then once and forever switch over to OpenConfig, or the other way around, you start with OpenConfig, switch to native, and once and forever, and never look back. Switching an existing device day 2 may provide hundreds of services. To use OpenConfig once and for all may also work. There are more things going on here, so the risk is higher, but if you switch over and it does work and pass all your tests, it will usually stay working. Mixed transactions, which updates both native and OpenConfig models at the same time, are different matter, however. Heavy dragons. It may work. Sometimes it works just fine, but there are no guarantees. And if things stops working, the reaction from device vendors or NSO will likely be that it's not a supported use case and that you are on your own. Also, even if it's working, there's always a risk that even minor changes to the configuration or a software upgrade break things completely. All right, so long live. Which AI model should we use and for what use cases should we? NSO doesn't really care what device models you use. Doesn't matter if it's OpenConfig or ONF or native or whatever. It also doesn't matter what versions of models the device is using. This is because we are using templates in our service codes, and the templates hides the implementation details from the services. It doesn't matter if it's native or OpenConfig, it doesn't even matter what device it is. It's common to support services for several different types of devices in your network, and there are no particular reason to prefer OpenConfig or any other standard module set over another. The extra effort to support a different set of modules in the NSO environment is small. It's certainly nice if all devices look the same, but if the standard model isn't well implemented in the device, it will likely require more work than using native models. Also, by requiring devices to support a particular set of modules, you limit your options and may have to pay more or choose from devices that are worse in some other aspect. That is also important. At the moment, and many customers ask for it. We are happy to work with OpenConfig even though we don't see a strong reason to. If you have devices with well implemented OpenConfig interfaces, go ahead and use them. But if the OpenConfig models are older, you should be careful. You will likely have to jump through lots of hoops to make things work, and we are not sure it's worth the value. Not sure we see the value. Many devices, even with recent OS versions, have old OpenConfig modules, and few devices are OpenConfig native. And finally, and never mix model universes. It will only give you grief. With NSO templates shield you from the different vendors, versions, and module families. Just choose one module family for each device and stick with it. And if you run into any problems, the NED team is here. Finally, a short list of resources. We have NSO on DevNet and NSO Developer Hub for general NSO information and a great set of learning exercises at NSO Learning Labs.